Alright, we're doing geometry. Chapter 5, Section 4, Equilateral and Isosceles triangles. Okay, so here's an isosceles triangle, indicated by these two marks, meaning this side is the same as this side. We call those sides legs. That's a leg right there, and this is a leg. Okay, this down here is the base. So these two angles by the base are called base angles. And this up here we'll call the vertex. So that's the vertex angle. So vertex angle, base angles. Okay, what can we know about an isosceles triangle? Well, the base angles theorem tells me that if the base angles, or the other way around, sorry. If the two sides are congruent, then the base angles are congruent. So if I know it's isosceles, I know that the base angles are congruent. And the converse of that is if the angles are congruent, then the legs are congruent. All right. The proof of the base angles theorem. Given that AB is congruent to AC, prove that angle B is congruent to angle C. So the first thing you should always do for something like this is give yourself a visual. All right, draw yourself a picture. Like this triangle right here. Here we have an isosceles triangle. So the idea is we could use a bisector, angle bisector, and then prove parts of it using that. All right, so that's the first thing we'll do, and then we know that by definition of that angle bisector, that this angle CAD is congruent to BAD. That's an angle bisector, right? We know that this side and this side are congruent, so now we have AD, we have AC. Okay, maybe you can, and we have that angle in between them. You can maybe think, kind of get where we're going with this. Okay, by reflexive property, AD is the same as DA, or DA is the same as DA. And then we can say that these two are congruent by side angle side. Okay, and because corresponding parts of congruent triangles are congruent, I can say that angle B is congruent to angle C. Alright, using the base angles theorem. In this triangle, DE and DF, we know that starting over. In triangle DEF, the side DE is congruent to side DF. Therefore, we know angle E is congruent to angle F because of base angles theorem. The corollary to the base angles theorem is in an equilateral triangle, it has to be equiangular. And the corollary to the converse is if it is equiangular, it has to be equilateral. Very nice, very nice. So finding the measures in this triangle. We want to find the measures of these angles. We know that it is an equilateral triangle. Since it is equilateral, we know it must be equiangular because of the corollary of the base angles theorem. Since it is equiangular, all three of those angles are the same. So the measure of 3 times the measure of one of those angles, P, is 180. So we can divide that by 3, and the measure of angle P is 60 degrees, which is equal to the measure of angle R, which is equal to the measure of angle Q. All right. Using an isosceles and equilateral triangles, find the values of x and y in this. Because we know that this is equiangular, corollary base angles theorem tells us it must be equilateral. Therefore, y is equal to 4. Therefore, an L is also, NL, there we go, is equal to 4 because this is equilateral. And because of base angles theorem, we know that this side is also equal to this side. So, since we know NL is 4, we know that NL is equal to x plus 1, and therefore x plus 1 is equal to 4, and hence x is equal to 3. There we go. Very nice. Alright, solving a multi-step problem. In this lifeguard tower, PS is congruent to QR. PS right here is congruent to QR. And angle QPS is congruent to angle PQR. Okay. Now, trying to envision what those two triangles are without getting distracted by the little triangles inside, you could redraw them and kind of scoot them out and have a look at them that way. So here we have triangle PQS, and here we have triangle PQR, and this is angle 2, this is angle 1. There's 4 down here, and 3 right there. And we also know that QPS, this angle, is congruent to PQR. Alright, so we know PS is congruent to QR. PQ is the same as QP. PQ is obviously congruent to QP. Reflexive. Okay, so therefore, side angle side, they are congruent. Now we want to explain why is PQT isosceles. PQT, so that's this little triangle in here. Well, we know from previously that angles 1 and angle 2 and angle 1 are congruent because congruent parts of congruent triangles. We weren't given that, but we have proved that these triangles are congruent in part A. So 1 and 2 are congruent, and base angles theorem tells us must be isosceles. Check. And there you have it, ladies and gentlemen. That's all for today. Check back in next time for another fun lesson. Woo!